Alright, so solving radical equations. Let's start with some basic ones. Square root of n equals 4. First I want to make sure my square root's on one side by itself. Get rid of the square root by squaring both sides. Square both, so square root of n squared is n equals 4 squared, you get 16. Okay. Example number 2. Square root of n plus 2 equals 8. Again, you want to isolate the square root of n, so subtract 2 from both sides first. Bring this down, so now I have the square root of n equals 8 minus 2, which is 6. But now to get rid of the square root, now square both sides. N equals 36. Next example, square root of a plus 2 equals 8. So notice, the a plus 2 is all underneath the radical. So I do not subtract 2 here. Okay? So since it's all underneath the radical, simply just square it. So not like the other one. Okay? So now this just becomes a plus 2 equals 8 squared, which is 64. Good. Subtract 2 on both sides, and I get a equals 62. Next example. Number 4. 8 times the square root of 2b equals 64. Isolate my square root. Divide by 8 on both sides. Square root of 2b equals 8. Get rid of your square root by squaring. So 2b equals back to 64. Finally, divide by 2. B equals 32. X equals the square root of radical 72 minus x. Is my square root isolated? Is it on one side by itself? Yes. So simply go to squaring both sides. X squared is simply x squared equals 72 minus x. What is it starting to look like? Should look like a trinomial, polynomial. Bring it over my x, bring it over my 72. So x squared plus x minus 72 equals 0. Factor. Leading coefficient is 1. That makes it nice and easy. X and x take my first spot. Factors of 72. So remember, this last sign being negative tells me that my signs are going to be opposite. So I have 9 times 8 is 72, which will give me a positive 1. So positive 9 minus 8 set equals 0. Set each one of these both equal to 0. So x minus 8 equals 0. X plus 9 equals 0. Here x equals 8. Here x equals negative 9. One more thing we have to do is we're going to go back and plug in. So we're going to say 8 equals the square root of 72 minus 8. 8 equals the square root of 64. 8 equals 8. So we can see that this works. We want to check the next one. Now, when we're taking the square root of these numbers, we're looking for the positive solutions. Okay? If it doesn't come out as a positive, then it's considered an extraneous solution, which is written on your packet there. Extraneous solution. So if we test negative 9, so we're going to have here testing negative 9. Negative 9 equals square root of 72 minus negative 9. Negative 9 equals the square root of 72 plus 9, which is equal to square root of 81. And we want just the positives here, so this is negative 9 equals 9. So negative 9 here will be considered an extraneous solution, so the only solution I want to use is x equals 8. Same type of problem, v equals square root of 30 minus v. My absolute value is already isolated. Square both sides. V squared equals 30 minus v. Bringing everything over to one side. V squared plus v minus 30 equals 0. Factor again. V and v. Factors of 30, that give me positive 1.
6 and 5.
Good, 6 and 5. So this is going to be a positive 6 and negative 5. Here v equals 5. v equals -6, solving those both for 0. Test both of these. If you test these both in there, you'll see that v equals 5 is a solution, and v equals -6 is not a solution, or considered an extraneous solution. Next example, m minus 2 equals square root of 3m minus 6. The absolute value, the square root is already isolated here, so I'm just going to square both of these terms. So squaring both of these, this becomes the quantity m minus 2 squared. So be careful here, okay? You have to FOIL this out. So m minus 2 times m minus 2. Okay, if you FOIL this, you're going to get m squared minus 2m minus 2m plus 4, or m squared minus 4m plus 4. If you could do this part mentally, I would definitely suggest it. So m squared minus 4m plus 4 equals, and then this side is just simply going to be 3m minus 6. I want to bring over your 3m, I want to bring over your minus 6. So subtracting 3m, you'll get m squared minus 7m, adding 6 to both sides, be plus 10, equals 0. Now you just want to factor this. M, factors of 10 to give me -7. Remember, this is a positive 10, so both my signs are going to be the same. In this case, they'll both be negative, so this will be 5 and 2. So minus 5 minus 2 equals 0. Substitute in, or solve these for both for 0. You'll get m equals 2 and m equals 5. If you substitute in here, if you substitute 2 in, you see you get 0 equals 0. So the m equals 2 works. If you substitute the 5 in here, you'll get m minus 2. 5 minus 2 is 3. And you get 15 minus 6 is 9. So you get 3 equals 3. So in this case, both m equals 2 and m equals 5 both work. P equals -4 plus square root of 6p plus 15. Okay, my first step is I want to isolate the square root sign, so I'm going to bring this over. So this would be p plus 4 equals the square root of 6p plus 15. Now we just want to go at this problem just like the last one. Square both sides. Okay, I'm going to do this one mentally here. So p squared. I'm going to double my 4p here, so I'm going to get 8 plus 8p plus 16. That's what I got after foiling this piece here. Equals, square that, I get 6p plus 15. I want to set this equal to 0. Bring everything over. So I'm going to bring over this 6p, so I'm going to subtract 6p. So p squared plus 2p. I'm going to subtract a 15, so plus 1 equals 0. Factor. This will give me p plus 1. P plus 1 equals 0. They both are the same solution here, so p here equals -1. Be careful when you plug in here. You might see the negative and think that this might automatically be an extraneous solution, but it's not going to be. So -1 equals -4 plus 6 times -1 plus 15. Just plugging this in. So the -1 equals -4 plus the square root of -6 plus 15. -1 equals -4 plus square root of 9. -1 equals -4 plus 3. And we see here that -1 equals -1. So p equals 1 is the solution. Okay, square root of -2n plus 23 equals -4 minus 4n minus n. They both have square roots in this case, so let's just square both of them. This one's going to work out nicely because our square roots are going to drop. So 2n plus 23 equals -4 minus n. So I don't have any squares. I just have one variable in terms. Let's get my variables on one side and constants on the other. So let's bring this -n over. So I'll get 3n on that side. Let's bring this positive 23 over to that side. Equals -27. Divide both these by 3. N equals -9. If you plug in here, you should get both sides are equal to each other. I believe you should get square root of 5 is equal to square root of 5. So n equals -9 would be your solution. Alright, so the square root of 2x plus 7 minus 3 equals the square root of 3x minus 3. If you notice, I'm always trying to isolate the square root, but wherever I bring the 3, it's not going to isolate it. Alright, so in this case, you're stuck with this. So just square it from here, because you still want to get rid of your square root. Alright, so this is actually going to create a little bit more work on this one, and see how. So this, we're going to have to FOIL this out. So I'm just going to FOIL this first one out for you. So 2x plus 7 minus 3 times radical 2x plus 7 minus 3 equals, and then when I square that side, I'll just get 3x minus 3. So if I FOIL this, radical 2x plus 7 times radical 2x plus 7 is simply 2x plus 7. Radical 2x plus 7 times negative 3 is negative 3 radical 2x plus 7. Then then distribute my negative 3. Negative 3 times radical 2x plus 7 is negative 3 radical 2x plus 7. And then negative 3 times negative 3 is positive 9 equals 3x minus 3. If you notice, I have two terms that are like terms, and I have the positive 7 and the positive 9 that are like terms. So I'm just going to rewrite this all. So 2x plus 7 plus 9, I get 16. Negative 3 radical 2x plus 7 minus negative 3 radical 2x plus 7. So it becomes minus 6 radical 2x plus 7, combining those terms, equals 3x minus 3. I'm going to isolate my radical. I'm going to bring the 2x over, and I'm going to bring the positive 16 over to the other side. So I'm going to have here negative 6 radical 2x plus 7 equals, if I subtract 2x, I'll have 3x minus 2x is 1x, and negative 3 minus 16 is minus 19. Now it's isolated. I can still divide by negative 6, but if I divide by negative 6 here, it's not going to create anything pretty on the other side. I'll create fractions, so I'm just going to square it here from this side. Square here. Negative 6 squared is 36, so I'll have 36 times the quantity 2x plus 7 equals, and I'm going to square this. So remember, this is going to be x minus 19 times the quantity x minus 19, so FOIL it. X times x is x squared, and double 19, so minus 19 times 2 is 38x, plus 19 squared is going to be 361. So here, let's distribute. 36 times 2x, 36 times 7. So 36 times 2x, I'm going to get 72x plus 252 equals x squared minus 38x plus 361. Solve for x, so I'm going to subtract 72x from both sides, and then I'm going to subtract 252 from both sides. So here, I'll get x squared minus, here's my negative 72x, will give me negative 110x plus, subtract 252, and I'll get 109 equals 0. That's nice. The 110, let me clean that. So the 110 here, and the 109, that should be a nice little hint. So when I factor this, x and x, factors of 109 that give me 110, 1 and 109. These will both be negative, z equals 0. So my two solutions here are x equals 1 and x equals 109. Next step here is to go back, plug these into your original, and see if you have any extraneous solutions. So if you plug in 1, you'll get 0 equals 0, so x equals 1 works. If you plug in 109, you'll see that this doesn't work. So your answer is x equals 1. One more example. So this one, same concept, okay? Let's square both sides. There's no way I can isolate the radical, so I'm going to get double the work on this one. So negative 3 minus x equals, I'm going to FOIL this one mentally, so 4 squared is 16. Okay, so you can do 4 times this and double it. So you'll get negative 8 radical 5 minus 5x, and again you could get this by FOILing it, plus, and then this would be radical 5 minus 5x times itself, so plus 5 minus 5x. Simplify where you can. So I'm going to get negative 3 minus x equals 16 and 5 is 21, minus 8 radical 5 minus 5x minus 5x. Bringing everything over to the left except for the radical. So I'm going to subtract 21 and I'm going to add 5x both sides. So adding 5x here and subtracting 21 here. See here, negative x plus 5x, I'm going to say 4x minus 24 equals negative 8 radical 5 minus 5x. Once I'm at this point, I still want to get my radical by itself. I have no choice but to square this. Okay, so I'm going to have 4x, you can FOIL this, 4x times 4x is 16x squared. I'm going to take 4 times 24 and I'm going to double it, so I'm going to get negative 4 times 24 is 96, 96 times 2 is 192 plus 24 squared. If I take negative 24 times negative 24, I'm going to get, one more time, 576 equals, this should have been, this whole thing's here, so this would be equals 64 times 5 minus 5x distribute in, so I got 16x squared minus 192x plus 576 equals 64 times 5 is 320 minus 64 times 5 is 320x. Getting to the end, almost done. Bring everything over, so I'm going to have 16x squared. I'm going to add 320x to both of these, so plus 320. So negative 192 plus 320, or 320 minus 192 should be plus 128x. Subtracting 320 from both sides, plus 576 minus 320, 256 equals 0. I have a leading coefficient. First thing you should do before you try to factor this, see if you can factor out 16. In this case, you can. So factor out 16. So I'm going to get x squared plus 8x plus 16 equals 0. Factor 16 times x plus 4 times the quantity x plus 4 equals 0. This will go away and you'll get x equals negative 4. If you plug back into your equation, x equals negative 4, you see the equation does not work. So this will be an example of a no solution.